Yeah, hi friends, welcome. Today we are going to see the software-defined vehicles, their components, how it works, what needed to define, and all those things about the software-defined vehicles. So what is a software-defined vehicle? Software-defined vehicles are the vehicles that rely heavily on software to control and manage the various functions traditionally handled by the hardware. In the SDV, the critical systems such as propulsion, steering, braking, and safety features are controlled and operated by the software algorithm rather than the mechanical components alone. The software-centric approach enables the greater flexibility, adaptability, and customization of the vehicle functionality. So basically, what are the components or the systems needed to define the software-defined vehicles? So this needs the advanced computing power. SDVs are equipped with the powerful onboard computers capable of processing the vast amount of the data in the real time. The reason because they have to synchronize the data from the cameras, lidars, sensors, and everything. Number two, the connectivity. SDVs are connected vehicles utilizing the communication technology such as 5G, Wi-Fi, and Bluetooth to interact with other vehicles, infrastructure, and the cloud-based services. Sensors. SDVs rely on the variety of the sensors including the lidar, radar, cameras, and ultrasonic sensors to gather the data about the vehicle surroundings. Software algorithms. To run this particular SDVs need a sophisticated software algorithms to interpret the sensor data and make the driving decisions and control the vehicle functions. Over-the-air updates is also called the OTA. SDVs can receive the software updates and patches over the air, allowing the continuous improvement, bug fixes, and the new features without requiring the physical intervention. Number 6. Artificial intelligence and the machine learning. Software-defined vehicles often employ the AI and the machine learning techniques to improve the performance and optimizing the driving behavior, enhance the user experience. Number 7. Advanced Driver Assistance System, that is ADAS. SDVs typically feature advanced driver assistance systems such as adaptive cruise control, lane keeping assistance, automatic emergency braking, parking assistance, and many others. Number 8. Human-machine interface, that is HMI. SDVs have sophisticated interface that allows the drivers and passengers to interact with the vehicle software and the controls of various functions. Number 9. Cybersecurity. Due to their reliance on the software and the connectivity, the SDVs incorporates robust cybersecurity measures to protect against hacking, unauthorized access, and data breaches. Number 10. Modular architecture. SDVs are designed with the modular architecture, allowing easy integration of new features, components, and capabilities. Overall, software-defined vehicles represent a paradigm shift in the automotive technology, offering the enhanced safety, efficiency, user experience through the integration of advanced software systems and connectivity features. So, which are the companies are using the software-defined vehicles? Tesla. Tesla is known for its electric vehicles and advanced driver assistance systems and the software features such as autopilot, full safe driving capabilities, and over-the-air updates. Waymo Alphabet. Waymo is a subsidiary of the Alphabet Google parent company, focuses on developing the autonomous driving technology and has been testing the self-driving vehicles extensively. Number 3. General Motors. General Motors is investing heavily in electric and autonomous vehicles with its Super Cruise driver assisted technology and plans for fully autonomous vehicles in the future. Ford. Ford is developing the software-defined features for its vehicles, including the Ford Pass app for remote vehicle monitoring and control, as well as its Copilot 360 driver assisted technology. Number 5. BMW. BMW is incorporating the advanced software features into vehicles such as its BMW Operating System 7, which offers over-the-air updates and advanced driver assistance systems. Number 6. Audi. Audi's latest vehicles features the Audi MMI infotainment system, which integrated advanced driver assistance system and advanced software for navigation, entertainment, and connectivity. Number 7. Mercedes-Benz. Mercedes-Benz is known for its M-Box Mercedes-Benz user experience infotainment system, which offers advanced voice recognition, navigation, and connectivity features. Number 8. Volvo. Volvo is focusing on the safety and the connectivity of its vehicles, incorporating the advanced driver assistance systems and connectivity features into its models. Porsche. Porsche is incorporating the advanced software features into its vehicle, such as Porsche Communication Management System, which offers the navigation, entertainment, and connectivity features. Rivian. Rivian, an electric vehicle startup, is developing the software-defined features for its electric trucks and the SUVs, including advanced driver assistance systems and over-the-air updates. Number 11. Lucid Vehicles. Lucid Motors. Lucid Motors, another electric vehicle startup, is focusing on the software-defined features for its luxury electric vehicles, including its Lucid Air sedan. Number 12. NIO. NIO is a Chinese electric vehicle manufacturer. It is incorporating the advanced software and connectivity features into its vehicles, including its new pilot driver assistance systems. So these were some of the examples. There are many other companies using the driver assistance systems and the software-defined vehicles. Renault, Peugeot, Stellantis. There are many car companies out there. So basically, what are the key components? It must have the very high performing computing platform. Sensors should be reliable. Connectivity, software frameworks, algorithms, and AI, HMI, over-the-air update systems, security systems need to be there. Redundancy and the fail-safe mechanism. The reason because SDV employs redundant systems and fail-safe mechanism to ensure the safety and reliability, even in the event of the software or the hardware fails. This includes redundant sensors, actuators, and control systems, as well as backup power sources and emergency braking systems. Simulation and the testing tools must be there to simulate the whole vehicle, how it performs and everything. So now let us see what are the risks for the software-defined vehicles. If anything connected with the software, it means anybody can enter in that software. You cannot be 100% fully safe or safeguarded. So let us see the risk for the software-defined vehicles. Number 1 risk is cybersecurity threats. SDVs are vulnerable to the cyber attacks, including the hacking, malware, unauthorized access to the vehicle systems. Malicious actors could exploit software vulnerabilities to gain the control of the vehicle, compromise safety systems, and steal sensitive data. Number 2. Software bugs and the glitches. Like any complex software system, SDVs are susceptible to bugs, glitches, and software errors that could affect performance, reliability, and safety. Even minor software bugs could have a significant consequence if they impact the critical vehicle function. Number 3. The system failures. SDVs rely heavily on software to control the essential vehicle's functions, raising concerns about the system failure due to the software malfunctions, hardware defects, and environmental factors. A single point of failure in the software or hardware could lead to accident or loss of control. Number 4. Data privacy concerns. SDVs collect a vast amount of the data about vehicle operations, driver behavior, surrounding environment, raising privacy concerns about how this data is collected, stored, and shared. Unauthorized access to sensitive data could violate privacy rights and lead to identity theft and surveillance risk. Number 5. Liability issues. Determining the liability in the event of accident or incident involving SDVs can be complex, especially if the cause is attributed to software failure, sensor errors, and system malfunctions. Clarifying the liability frameworks and insurance coverage for the SDVs remains a challenge. That's why the functional safety and the cyber security comes into picture, where they define the responsibility sharing about the functions failure and all this hara analysis. Number 6. Regulatory and legal challenges. The regulatory framework for SDV is still evolving, with policymakers grappling with the issues such as safety standards, certification requirements, liability laws, and data protection regulations. Legal ambiguity and regulatory uncertainty can hinder the widespread adoption of SDVs. Number 7. Ethical dilemma. SDVs raise the ethical dilemma regarding the decision making in critical situations. such as determining how the vehicle should be prioritized, the safety of occupants versus the road users, or how it should respond to unavoidable accidents. Resolving these ethical challenges requires careful consideration of societal values and moral principles. Number 8. Dependency on connectivity. SDVs rely on connectivity for communication, navigation, and software updates, making them susceptible to disruptions in network connectivity, cyber attack, electromagnetic interference. Dependence on the connectivity raises concern about the reliability and vigilance in remote or poorly connected areas. Number 9. Rapid technological advancement. The rapid pace of the technological advancement in SDVs poses challenges related to obsolescence, interoperability, compatibility with legacy systems. Keeping pace with the evolving technology requires continuous update, investment, and adaptation to the new standards and protocols. Number 10. Social acceptance and the trust in SDV. Building public trust and acceptance of the SDV is crucial for their successful adoption and integration into the society. Addressing concerns about the safety, reliability, privacy, ethical considerations is essential to gain the widespread acceptance of SDVs among the consumers and stakeholders. Addressing these risks and challenges requires a collaboration among automakers, technology companies, policymakers, regulators, and other stakeholders to develop robust cybersecurity measures, establish clear regulatory framework, address ethical considerations, and build public trust in SDVs. So many there are ongoing research is there, testings are there, validations are there going on to make sure these SDVs are coming into the market and their adoption. So let us see the 10 things you should know about this one. Basically, the software-defined vehicles is a term describing vehicles where many functions traditionally handled by the hardware but now controlled by the software. SDVs are using the advanced computing power and connectivity to enhance the safety, efficiency, and user experience. SDVs enable over-the-air updates, allowing for continuous improvement and bug fixes without the physical intervention. These vehicles utilizes the sensors such as LiDAR, radar, and cameras to gather real-time data about their surroundings. The software in the SDVs processes sensor data to make driving decisions such as lane keeping, adaptive cruise control, and collision avoidance. Machine learning algorithms play a crucial role in the SDV, enabling them to improve the performance over the time to experience. Cybersecurity is a significant risk in the SDVs. Important thing, the edge computing is needed for the SDVs to make their successful launching. So basically friends, these were all the things about the software defined vehicles, what it is, what are the risks in the SDVs adoption, what are the components needed in the software defined vehicles. I hope you know much more information about the software defined vehicle, what is the software defined vehicle, components usually need, what are the cyber security risks and the threats for the software defined vehicles adoption and product in the market and the mass scale. Thank you very much friends. We'll bring something new every day, sharing the knowledge, sharing the value. Thank you very much for listening. See you in the next amazing video friends. Thank you.